All right, we're being asked to simplify the division of these radical expressions. The first thing that we're going to do is cancel common factors within the radicals. And we're going to use this property up here, by the way, is that if you have the square root of a over the square root of b, that is the same as the square root of a over b. What that means in our case is even though that these are in two separate radicals, we can envision them as being in one single radical. And so what that means is I can cancel, for instance, between the 8 and the 18 and the 4, I can cancel the common factor of 2 and get a 9 up there and a 2 down there. I can cancel two sets of the a between the numerator and the denominator, get left with an a to the 4th down here. And then I can also cancel, let's see, a b to the 4th, a b to the 10th. I can cancel 4 of these b's with 4 of the b's up here to be left with a b to the 6th up in the numerator. All right, so what that gives me now is I have a 9b to the 6th up here in the numerator. And in the denominator, I have a 2a to the 4th. All right. So that was just canceling common factors. Now what I'm going to do are simplify each of these radicals separately. And you just got to be good at simplifying radicals, these square roots. This is a little bit crazy here. The square root on top, I take the square root by taking the square root of the 9 and the b to the 6th. That would give me 3b to the 3rd. Again, because the square root of 9 is 3, and the square root of b to the 6th is b to the 3rd, because I divide that exponent by the index of 2. That's out here on the square root. Let's see, now the square root and down here, I can't take the square root of the 2, so that's going to stay in there. A to the 4th, the square root of that is a squared. All right, what we've done now is pretty much simplified this as much as possible. The only exception is I'm not allowed to have my final answer have a radical in the denominator. There are many reasons for this, but we won't get into the details. What I need to do is modify this fraction so that it doesn't have a radical down there. The beautiful thing about the square roots is that all I need to do in this case is multiply the numerator and the denominator by the square root of 2. And why I do that is because square root of 2 times the square root of 2 is just 2. So again, on the side, I'll write this up here. This is an important understanding, is square root of 2 times the square root of 2 is just 2. You can verify that, put them together, that'd be the square root of 4, it's 2. It always works out like that. If you multiply a square root by itself, you always just get the stuff on the inside. So what that means is all of this, a squared, square root of 2 times square root of 2 is 2a squared. I've successfully gotten rid of my square root in the denominator, so that looks good. And then on top, I have 3b to the 3rd times the square root of 2. And that is my final answer, and I'm completely simplified. There's no factors that I can cancel between the numerator and the denominator. And the radical parts are simplified, and there's no radical in the denominator.